So what I'm going to ask you to do try to get you to do with this kind of question is find some definite integral out of the book that requires a u-substitution. This would probably be out of 6.2. Okay, and then what you're going to do is start to do the setup, and then you're going to create a multiple choice question where one answer is right, three answers are wrong, of what you would do to do a u-substitution to solve this. And you'll see. I'm going to walk you through this and do this. So how would we do this problem using a u-substitution? Well, I'm seeing that the derivative of t squared is 2t. So I'm thinking this would make a good choice for u. You know, the other thing is you've found out that when you're given a fraction, often part of what the u will be in the denominator. So I'm going to say u equals 4 plus t squared. So du equals 2t dt. And something else I should do is break this up, this whole integral up into integrand up into some parts, because I know that's been giving some of you a hard time. So 4 plus t squared cubed times 2t times dt is another way to think of this whole rational expression. Might make it a little easier to do. So what I'm seeing is I see this 2t times dt, and that's exactly what du is. So that whole thing get replaced with du. And I'm seeing that I can replace the u, of course that I kind of set that up. That gets replaced with u. So 1 over u cubed. And then when I integrate that, and of course this is a definite integral because I have my bounds. If I were to do this all the way out, I'd have an answer, a number answer. So what you have to remember to do is to, let's see, what's u of 0? Well, if I replace t with 0, 0 squared is 0, plus 4 is 4. And then what's u of negative 1? Well, negative 1 squared is positive 1. 4 plus 1 is 5. So that means in my integral I can set this up as, and this is what I did, negative 1, when x is negative 1, the new bound is 5. And when x is 0, the new bound is 4. You've seen some problems like this in the homework, if you've done the homework yet. So the other thing I'm noticing about this is that this integral is that the 5, these are reversed. The 4 should be on the bottom. So I'm going to rewrite this as negative 4 to 5, 1 over u cubed du. So what I've just created here is I've created two choices of my 4 multiple choice questions. This is one choice, it's the correct choice. This is a possible choice, but because those bounds are backwards, that's not exactly the right choice. Another mistake that people will make is they won't bother to switch those bounds. They'll leave the original bounds on the function. See, they just wrote those down. That's a mistake. You might have made this on the homework. Okay, so I guess to make it a 4-question multiple choice problem, we have to introduce another piece of error. Now, one error that I'm noticing that I made when I first did this is I noticed, well, I said, well, typically when I get a constant times this, I think, oh, well, I got to divide by 2. I'd automatically divide it by 2. But then I realized after I broke this out that the 2 can stay in there and I don't have to do that division. So something we could do to just play with people's brains is you could divide both. If I divided both sides by 2, and then I could even write in the right bounds 4 to 5. I could even stick a negative in front of it of 1 over u cubed du. So here's what I've got. I've got 4 choices. And one of those is correct. And here's my original question. And this is what I'd love to see with you. I'd love to have you make it. I mean, show me a little bit of this analysis and this thinking, explain to me what you did. I think that's a great question. So let's see what you can do with it.